YouTube and subscribe to Usman Chain Physics Maths class because it is free. Follow him on Facebook and TikTok. So let's get into it. We know that the unit of velocity is meter per second, and we said that to look for dimension, meter is length and time is t raised to the power minus 1, and that is the dimension of velocity. As I said earlier, we'll be using another method. So I will say number 1 is velocity. Velocity is always displacement, and displacement is represented either by S or T. Okay, so S is the displacement and T is the time taken. Sometimes we can replace it with what? D. All right, the same thing. So in my last video again, I have said that distance, displacement, length, height, breadth, all of them, their dimension is L. Okay, their dimension is L. Remember, distance, displacement, height, breadth, length, all their dimension is L. Okay, so if this is distance or displacement, then it means that the dimension is L. So we said this is equal to L over time is always T. All right, if that is true, this can also be written as L multiplied by 1 over T. L times 1 is something as L over T. Okay, so 1 over T, and in this we can also write it like this. We can say velocity is something as L times T raised to the power minus 1. Okay, when you multiply this, our velocity will be LT minus 1. And this is the dimension of velocity. That is number 1. Okay, so we move down to number 2. Number 2 is force, and the unit of force is Newton, or is kg, meter per second square. This is the unit of force. So to look for the dimension, it will be simple. This is kg, is always capital M. The dimension of mass is capital M, and the dimension of length or displacement is always L, and dimension of time is T minus 2. And this is the dimension of the force, but we are using another method. So force is always equal to mass multiplied by the acceleration. Mass multiplied by the acceleration will give us force, and this will be equal to the mass. The dimension of mass is already capital M. Okay, so acceleration is change in velocity with time. But we know the dimension of velocity from here, all right? The dimension of velocity is Lt minus 1. So we replace it immediately. So this will be m times Lt minus 1 all over. Dimension of t is still this, okay? So if that is true, we'll say this is equal to m times Lt minus 1 times t minus 1, or we can say times t 1 over t, just like what we did here before. All right, so if that is the fact, we can say our force is equal to m times Lt minus 1 times, this is 1 over t, so we can write it as t raised to the power minus 1. All right, so this will be equal to m L t minus 1 times t minus 1. From the law of indices, you add the power, and this is minus 1 plus open bracket minus 1. All right, if you clear the bracket, plus times minus will give us minus, so we have minus 1 minus 1, and this will give us minus 2. So t raised to the power minus 1 times t raised to the power minus 1 will be t raised to the power minus 2, and this is the dimension of force. If you check, it's equivalent to this. All right, so this is how to find the dimension of force. So we are going to the last one, which is the density. Density is equal to mass all over the volume. All right, mass all over the volume. So these are, as I said earlier, if you want to look for the dimension of density, it's always very simple if you know the unit of density. The unit of density is kg meter per meter cube. Okay, and it means that the dimension of this, it will going to be a capital M, then L raised to the power minus 3. This is the dimension of density. But we want to use this method in looking for this dimension, so we have to go. Dimension of mass is capital M. We are done with that. So times 1 all over dimension of volume. Volume is given by length times breadth times height. Length times breadth times height will give us volume. All right, so if that is true, the dimension of length is L, dimension of breadth is L, dimension of height is L. So it means that we're going to be having L times L times L. So if that is true, we'll set M times 1 all over L times L is L square, times L will be L cubed. So we have L raised to the power 3. And this, in indices, we can also write it like this: M times L raised to the power minus 3. That is from indices. Okay, so we can say this is equal to M L raised to the power minus 3. As you all know, we said density, the dimension of density, always rho, is equal to M L raised to the power minus 3. And that is it. This is dimension of density, dimension of force, and dimension of velocity. That is all for what I have for you. In our next video, we'll be looking at application of this dimension. Make sure you subscribe to my YouTube channel so that